Welcome to Code Health at Google.
My name's Mira.
And I'm Hui Shen. Yep. Start with off, one fun fact about me, I work out 5 times a week.
Really?
Yes, I'm very fit.
Okay, that's pretty good. I work out 3 times a week. So my name's Mira. I've been with Google about 4 years, and I found something interesting. Apparently, 60% of people at Google are newer than me.
So you are a dinosaur.
Yeah, I've been here for too long. Before we get started, we have a chat moderator, Lex and Maya and Karthik. So if you have any questions throughout the session, feel free to chat away. Anything to add?
No. Ready to start. Okay, so is code health. So the question here is, can a code be sick?
Mhm.
Yes, a code can be sick. What do you think? What do you think are the characteristics of a sick code?
Sick code. I don't know. Hard to read.
Yes.
Hard to understand.
Hard to understand.
Mm.
Difficult to extend.
Mm.
Buggy, problematic to work with.
Mm.
So start with a case study of copy pasting.
Okay.
Question.
I do that all the
Quick
time.
question. You do that all the time?
Sometimes.
Okay. Should we be copy pasting? The answer is no.
Really? Never?
Almost never, yes.
Okay.
The
Good
reason
to know.
is because there are two folds. Number one is that if you are copy pasting, you probably can automate it. Second portion is that when you copy paste, imagine you have a bug in one of the function. And then you just copy paste throughout the code. So what you have done is you multiply the number of bugs throughout the code by that many times.
True. Okay. So
Then
you have to
if you
fix
want-
it many times.
Yeah.
Okay.
So if you want to fix it, you'll be like, oh, where did I copy paste the bug to, the code to? And then you have to go and spend a lot of time trying to write the mistake.
Very
And then
true.
the question is, who's taking the punch? It is most likely you, or your future teammates, or your current teammates. So please don't do that. What are some of the characteristics of a healthy code? A healthy code is one that is easy to understand, easy to modify and extend, resistant to bugs.
That's
And
tough.
this part tough. Yes, I agree. But one thing to remember is that even though your code can compile, can pass the test, a code is written once, but it's written many times. So even though it compiles, it passed the test, it doesn't mean that it is a healthy code. And more often than not, you will be the one reading the code many times.
Okay.
Like just me, I was like reading a code that I created a while back, and then I was like trying to understand it. So healthy code helps. Think about the timeline. Like in school, your code live for about maybe 1 week, 1 month, or maybe 1 year at most if you're working with a professor. At a startup, it can be from 3 months, which is a prototype, to a few years. And for big companies, code actually exists for a much longer period of time. So having a healthy code and maintain a good code health is actually does pay off.
Okay. Yeah. Very true.
I'll pass it over to you.
Yeah. Sure. That's quite true. I look at the code quite often, and I must tell you, I've seen code that's like 5-10 years old. It's really important because whoever wrote the code might not be in the team anymore, or not even be with Google anymore, right?
Sometimes they become your boss.
Yeah,
but
true, that is true.
Okay, that is
So like when you're reviewing the code to either to modify it or to reference it, when you look at the code, it's hard to understand. And if the person who wrote the code is not within the same team anymore, it's really hard to find out, right? So it's really important that you write the code, not just for yourself, but for the future.
Yeah, agree.
So as Huishan mentioned, you write the code once and maybe you look at it again second time if there's a bug to fix. But then once I submit my code, how many times does it get reviewed?
At least 2 approvers are required.
Meaning you have 2 more people looking at your code, and then say there are bugs to fix later on, someone will have to read your code again, right? And then every time there's a new team member, they'll probably look at your code and everyone else's code in the same team to understand what the product does and what the code does, right?
Yeah.
So as you can see, like you write it once, but it's being read many more times.
Yes.
So how do you write a code that's easily understandable, not just by yourself, but everyone who has access to the code, pretty much, right?
Mm-hmm.
So you can follow these 3 simple steps. Make your style guide best friend. Can you guess what the style guide is?
A style guide probably is some manual that talks about what style you should follow.
Okay, that's pretty good. Style guide is a set of conventions and standards to help you write how to write the code. Not how you implement the code, but like what kind of formats to follow, what kind of naming conventions to follow, etc. So it's at Google. There's a style guide for every programming language that's being used. So it's pretty universal. And it's religiously followed, and your code will be reviewed against it. So it's pretty important.
Yep, agree.
Yeah, should be your BFF. You can actually take that link and then take a look at what the standards are like at Google, and then you can use it for your own project.
Yep.
So now you have a style guide in hand. Now it's time to write the code. So when you write the code, when you pick variables or function names, make sure it's descriptive enough so that you don't have to look through your code to find out what it means or what it does, etc. When you write the block of code, make sure to do one thing and one thing very well. So it's called something called single what?
Responsibility principle.
Okay, she's gonna go through it in a bit in more detail. So make sure, and try to keep it simple. Don't try to make it complicated, because then you're doing yourself
a disservice.
Yeah, exactly. And once you write the code and you review it and see if it's understandable, you can actually, if not, and if it's a little vague, it's okay. You can leave some comments to add details. So now you've written your code following the style guide, and you submitted your code. It doesn't go into the code base right away.
What happens? It doesn't. It goes through a code review.
Okay, and very rigorous one, especially at Google.
Tell me about it.
At least it gets reviewed by 2 or more people, and then they'll actually look at the style guide and to make obviously they'll make sure that the code does what it's supposed to do, but they'll also look at the style guide to make sure that you follow the standard that Google has set.
You just reminded me. I just have a CL that has like maybe 6-7 comments.
That's it?
Hope not more. Okay.
So here's a example of some of the not so well chosen variable names. So you can see on the left top box, it says I, num, str, map. I can kind of guess what it means and what it does, but it's really subjective in a way, right?
Yes.
So instead of choosing variable names that's really vague, you can go with the one on the right top hand. So instead of using I, you can use card index, UID, I would say user ID, or names by alpha. Okay, that's
no
still
I do not know why it's named.
It's still a little vague, but
okay.
Anyways, you get the point, right? But there are always exceptions, right?
Yes, there's exceptions.
Yeah, so if something is very well understood amongst the developers and coders, then you can actually use those even if it's not so obvious to maybe non-developers. For example, I in the iterator or S in the S or str in normalizer functions, you can use those.
Yep, especially when the code is short and
right,
it is a counter, it is fine.
Yeah, because if you try to use different names, then you're kind of making things a bit more complicated.
Engineers are not very good with names, actually.
It's
creative.
Just follow the rules.
Yeah.
And Hushan.
Okay, I'll cover about naming. So what is about naming? So when you create a variable, a function, you only have one intent in mind. So you have to think about why you create that function, why you create that particular variable. Okay. And then with that in mind, then you can give it a better name. People have a very short attention span. So let's not try to give variable names such as X, Y, or Z, and people have to go through all the way up to a declaration to try to understand what is X and Y and Z.
I hate it.
Me
scroll all
too.
the
But
way
then I'm also equally guilty of doing that. But okay. Next, I'll talk about the single responsibility principle. What it is trying to say is that whatever code that you're trying to write, whether is it a block, a class, or a function, just make sure that it is only doing one thing.
one thing very well.
Just one thing very well. Do not conflate it. If when you write a comment for the block of code and you have to use words such as and also, then a lot you should be like, I think something is wrong. I should be breaking my code down into different blocks or write different functions for it. We will go through some examples. Like for example, on the code on the left, it says self-driving, and it has start the car, it has other functions inside, versus the code on the right. It has each of the function is only doing one thing and doing one thing really well. And then after that, the main function, which is self-drive, it calls all the other function. The code on the right is a better one because I can easily extend it without affecting the other parts of the code. Versus the one on the left, I probably have to avoid have to read through each line of the code to understand what does start the car do, which is a waste of time actually. Sometimes it would be easier if your comments are good enough. You can bypass it. And you will ask, but nothing has changed. And it is true, actually, nothing has changed. But what you have done is that the teammate, your future teammate, will find it a lot easier to extend the code.
So, I want to join your team.
Oh, really? We have openings. Oops. Anyway, now, quick question. Can you count how many Noogler heads are there?
23.
I think you need to count again.
Okay, 25.
Okay, how about this?
Oh, okay.
So in this case,
6 times 4.
Yeah, and
24.
Okay, you passed your math. Okay, but then what I'm trying to say is that codes that are well organized, well compartmentalized.
Looks better.
Not only looks better, but easier to understand.
Right.
Compare about code and G. Think of G in Google. Our code is a lot more complex.
True.
It looks something like this. It's complicated. But then if the code is well organized and well documented and commented, then it is easier to understand and to extend it. So code health is important. Another SRP example is like, let's look at the class user manager. It says that the user manager class has to returns and has to fetch a user and also a cache a user.
Okay.
So the word also should rings a bell. It means like trying to do two things at the same time. So it is a good idea to split it up into two classes instead. How about this? Start server. Again, starting a server is actually quite difficult.
Right.
Involve many steps, server params, initiate database, connecting to service, etc. And so what do you think of this code?
Looks pretty long, but looks fine actually.
Okay. But then you're right. This code is actually as well organized as it is already. So you're right.
Okay.
Nothing has changed, and this code is actually a good code because I can easily extend it without affecting the other parts of the code.
Yeah.
Over to you.
Yeah. So, the last example had a lot of methods inside the one class or function, but I think it's pretty it's easily understandable, right? So I guess like single responsibility is something that you always want to keep in mind, but after your code does what it does, don't try to be too clever. Okay, sometimes it's better to leave things simple and try not to make it complicated. Okay, there's a second principle that we're going to talk about. KISS. Can you guess what it is?
It's already there.
Okay,
keep it
there.
simple.
Yes,
silly.
yes.
Yeah.
So don't try to make things complicated. If you can keep it simple, it's actually harder to keep things simpler than making it more complicated. You can add a lot of stuff, but then sometimes it's making it simpler is actually a tougher job, I feel like.
Yes, keeping simple is actually quite tough.
So we have a interesting example here. It looks like someone's face, right?
Yes.
Can you actually read what the code does?
No, I cannot.
Yeah.
But it just looked fancy.
Yeah, it looks pretty fancy, right? But then imagine you're trying to fix a bug, right? Even trying to find which line has an issue would take a long time, right?
Agreed.
So, I mean, don't try to be fancy, make it simple. Like I write it in like, normal format, line by line. It's easier to reference it as well, right? Another thing that you want to keep in mind is, it's an interesting one. You ain't gonna need it. Then?
So don't write it.
Okay, great. Yeah, so if you don't need it right now or tomorrow or in a month, don't, like, why?
You
why
probably
spend time?
don't need it.
Yeah,
yes.
exactly. Why spend extra time to write something that's actually not needed anytime soon, right? So here's a good example of extra things you're trying to do. So imagine you're writing a cache for System X, and then you're in a designing mode, and then you all get excited, and you think about all the ways you can write this code, right? And then you're like, oh, I can make it configurable, like,
sounds cool.
Yeah, dynamically fetch something, etc. Or you're trying to create different layers, interfaces to do it, or you're trying to write an external API so other team at Google can reference it, etc. Well, it sounds great. Like, sometimes as a developer, I think you want to do something cool and fancy and nice.
And big impact.
Exactly, yeah. But before you dive into deep coding mode, I would actually ask these questions. Do I need it today? How likely do I need it tomorrow or in a month, right? And if you don't really, if the answers to all these questions are no, then I would actually park that item. Like if I don't have to write it, and if Huishan has to write it in a month, I'll give it to her gladly.
Okay.
So third principle.
Oh my God.
Don't repeat yourself. So it kind of goes back to your copy and paste example. So here it's trying to fetch something from database. So it's trying to query different tables. So you're opening a connection, and then you're trying to run query, and then closing connection, etc. Right? Instead of having the same code twice in your class, how about doing this? It's similar to copy and paste example. Trying to pull those out and create a separate class or method to opening connections and closing it, etc. This way, if there's anything wrong with the code, you only fix it once. So you followed all these rules. You've written amazing readable code. Sometimes, like, even if you wrote the best code, there might be some vagueness that your code has, and then you might have to, clarify it, right?
Yeah.
So comments is a great way to kind of solve that problem. But before we talk about what comments should do, some things you should keep in mind. You shouldn't write a comment to replace what your code is supposed to do, right? And if it has a bad names, don't try to explain in your code, right? Fix your variable name, right? It's better that way. And so also, I've seen this a lot. Sometimes people kind of regurgitate and trying to summarize what your code is supposed to do. Not a best use of comments.
Yeah, and most often than not, I will see for loop and then on top comment iterate. I'm like, yes, I can understand that.
I can see that, right? So your comment should explain why and not how. How should be pretty self-explanatory by looking at your code itself. Okay, so you can use comments to give extra context about what your code is supposed to do, etc. And if there's something that happens outside of your code that you have to wait for some other team to do something, you can add that in the comment, because it's not something that's very obvious from looking at your code, right? And can't really read. Clarify. Yeah. So if there's any vagueness that you have to explain in the code to make sure it's more readable, that's something good to add in the comments section. So here's one example that you kind of mentioned. Let's look at it. It's a for loop, right? And then you have a comment at the top saying it iterates all the cards, right?
Mhm.
So it's pretty self-explanatory, your code itself, right? So similar to what we talked about, if it's pretty obvious to by looking at your code, just remove it. You don't need extra comment to talk about that. Second example. So we talked about naming, right? It's when you choose a name, make sure it's descriptive enough, right? So so you have X in there, and then you have a comment explaining what X is supposed to contain, right? What about you just rename it? So just call it normalized instead of X.
Yeah, agree.
And then, okay, so here's the interesting one. What do you think is wrong with this?
It says compute the discounted price, and then there's this function expression in there. But then I was like, okay, why cost equals to, you can have if I were me, I'll probably write it slightly differently.
Yeah.
I'll probably have a function for it, but okay.
Not the worst example, but you can make it better, definitely. So instead of like trying to do everything within the variable declaration, you can just create a separate method or function to actually compute that and make it pretty obvious. Say compute discount price or discounted price. So in that way, you create another method function to do the method itself in there. Right? I think it's easier, simpler, it looks better.
Yeah.
This is a pretty common example. When you create a class, you should write an extra comment to reiterate what it does. So instead of just having the name in the comment, what you can do is you can kind of explain a bit further what this class is supposed to do. Another example here. To do is a pretty common example. But then if you read through the comment, it's actually something you can do right now. Then why don't you just do it now? You can just leave the comment that's useful for other people and just delete the rest of the code. Here's another few examples of good use of comments. So say I'm waiting for something to happen in the future and I can't really change anything until this is done. That's a great way to capture it there as a comment. Because like by looking at your code, it's not going to be obvious at all.
Yeah.
So the next time, I'm on vacation, Q4 comes, Wishan can go in and complete the code. Here's another example. So this is quite, it's interesting one. I mean, do you really need it? Maybe it is pretty obvious when you review your code, but then say your manager comes in and like, I want to see what Huishan did for last quarter, right? And maybe or some other team has to use your code and reference in their project, right? Instead of them trying to read through all your code to understand what it does, if you can kind of summarize everything in the comment, what parameter you need to pass in to use my class, and then what value it returns, I save a lot of time, right?
Yeah.
Great example. Also, okay, so this one's also quite interesting. As much as you're trying to write a readable code, sometimes you might need domain knowledge to understand what your code does, right? So in that case, you can add more information in the comment section so that it gives more, I guess, clarity when they review your code, and then it gives you a good idea on what the code should do, right? So I'm done submitting my code with all the comments.
Good job.
It's your time to view.
Yeah. The next part is code review. So in Google, we want to have good code health in our code. So we have a code review process. Code review process is a process in which you send your code to 2 other peers, usually, for them to go through your code to see whether you are in line with the style guide, and to make sure that everything is good before it enters into the code base. So code review, usually it is a lot of things. It is whether your reviewer can understand the code, how fast they can understand the code. Is that a better way to implement? Sometimes, usually through code review, for me at least, I learned a lot because my teammates will come in and say, hey, have you considered this implementation? This implementation is a lot better, is more in line with the existing code and architecture. You should do this. And lastly is whether it have tests. The test is just to ensure that the code that you've written is doing its job well. So the code reviewer and the programmer usually have a frenemy kind of relationship. Sometimes I'll be like, can you just let me pass through, just approve it?
It works.
It works. All tests pass. Just let me pass. Sometimes there'll be comments on variable. I'm like, come on, man. It is already very clear. But then, this friend, even though they have this slight opposing relationship, there's only one goal in mind, and that's to have maintain good code health. So actually, this code review process is actually a way to build durable code in Google. And how do we keep bugs out? One of them is testing. Testing is really the last line of defense because I can write tests, ensure that my code is doing its job, but then it doesn't necessarily mean that it is a healthy code, as I said earlier. The code can still be fragile, the code can be good. Fragile code is a code that is error prone, it's difficult to extend, hard to understand, whereas robust code is one that resists bugs, easy to extend. Your teammates will love you if you are writing robust code. So how do you pass through code review? Actually, it's the same question as asking yourself to put yourself in the next person's shoes. Will there be new parameters? Will there be new behavior? If I want to add something, will it be easy to add? Or do I have to change many parts of the code just to make sure that one thing works? Whether the code is easily understandable, does it mislead the reader in any way? And lastly is how does the calling code looks like? When I look at a calling code, can I understand it? So we'll go through some examples. So the one on the left, it says permission.grant, takes in an object, user, and then there's a string read. A string read, does it cause, do you feel something is wrong?
Read what?
Okay, number one is read one. Number two is, what if I have a typo? Is it case sensitive? Is it case insensitive? Will the method take care of it? So a better way to do it is to use enums, then in which you eliminate all the typo mistakes altogether.
Just capitalize everything.
Yes. Another example is the generate PDF function. It takes in an image and then it has a whole bunch of booleans in there. This code is not very friendly because, say for example, tomorrow I want to add in a new flag. Then all the old codes that I've written so far will have to change because I add in an extra field. This type of code is very prone to error. A better way is to take in a list. So then, I can add in extra flags and then all the old codes I've written will still work. Another example, so let's take a look at this. Generate PDF. False, true, false, false, true. Can you understand what flex is false and what flex is true?
Of course I do.
Really?
Kidding.
You have to go back and forth, right?
I'll have to scroll all the way up.
Yeah, but versus the one on the right, it says, include header and timestamp. So the code on the right is easier to understand, it's better. Another thing is primitive types. Sometimes people are very obsessed with using primitive types. Versus aggregating it into something that's more meaningful. I know that it can be slightly contentious because if you can make it into if you can have a more meaningful representation, it might be easier. Let's take a look at the code here. So there's a draw circle function here. The one on the left takes in a class of point, color, and a float. Whereas the one on the right, they're all primitive types, all floats. Well, nothing is really wrong. But let's look at the calling function. The one on the left says point. I can immediately say, oh, 3.0 and 4.2 is the location of the point, and then the RGB color representation, etc. Versus the one on the right is all 3.0, 4.2. Can you tell me what does 1.0 refers to?
Point? Color? I don't know. I have to guess.
Yeah. So if you put it all together, you realize that the one on the right is harder to understand in terms of call stack. So the one on the left is better.
I can see what you did. You mixed it up. Left is the right one.
Yeah. So come to the end. Yeah.
Okay. Oh my God. We cover so many different principles. Keep it simple. You ain't gonna need it.
Single responsibility principle.
Wow, so many things to remember.
Yeah. But the deck would the deck be there? But okay.
So how do you remember all these things, right? First of all, style guide should be your best friend. And the way to pull everything together, try to write a sustainable code, right? So sustainable code is easy to read, easy to modify and scale, and something that's resistant to bugs.
Yep.
And when you do this, you have to keep other people in mind. Maybe it's not so natural, but like trying to write the code, not just, for yourself as well, for the future yourself who has to go back to your code and might have to fix it like later on, right? So you're ready for the future, you're ready for the reader, and whoever has to reference or call your functions, right? So when do you actually apply all these, right? Obviously, first time when you're writing it, and you look at the code, and it's not as healthy as you like to be, and that's when you can do some sort of refactoring, right? So refactoring is improving the design of existing code, right? You're not really changing the meaning of it or like behavior of it, but you're making it easier to read and understand. This happens quite often at Google, if you like.
Yeah, my team always does refactoring all the time.
Yeah, I guess good pulse check. So when do you actually do refactoring, right? Obviously, when you say your new team member joins and say like they spend hours trying to understand your code, I think that's pretty good time to sit back and trying to make it better, right? Also, when you're making changes to your code and you find it's not so easy you can't remember everything you did and it's not so easy to understand, that's a good time to refactor as well. And then what else? So, when you're experimenting with something, you know how when you want to just like write a simple code, simple and dirty, right? Quick one, and just to make sure it tested out your ideas. And now it works, but it's not very readable. And I guess that's when you go back and write the real code. That's when you can do a little bit of refactoring as well. Also, tests, very, very, very important.
Yes.
And in order to write the good test, you have to fully understand what your code does, and then you kind of write a test to make sure that it does everything it's supposed to do and not other things, right?
Yeah.
So, wow, we cover a lot of things. Some things, maybe you've heard it before, but sometimes it's not very natural, right? Like, sometimes you just want to make things work, and then you don't really think about all the things that we talked about today. But just have it in your mind and just keep applying them. I guess make it into your habit, and then I guess one day it will become your second nature.
Hopefully.
So we cover a lot of stuff today. Anything else you want to mention? Last word?
No, not really. Oh, if you have any questions, you can leave it on the live chat. The chat moderator will actually pass it to us.
Okay. Well, we'll pull up our phone.
Laptop. Yeah, let me take
for any questions.
Oh, wow.
Is there any questions?
Are there any questions?
You have to show speaker notes.
Okay.
Can I ask you a question?
Huh? Wait. There are questions here. Okay.
Okay. Yeah.
How is it the same? How does Google adopt a new programming language for a legacy system? When someone writes with older languages like C, will it get updated or rewritten in newer language?
This depends.
Yeah. It depends on whether the code is going to be reused or not. If it's going to be reused, then it's most probably going to be rewritten.
But I think we did actually have style guide for a long time. So
Yeah.
I mean, most of it should be pretty readable, unless something's wrong and you have to fix it, and it's not readable anymore. Then we might do a project to write it more cleanly and more readable. But in general, if it works, then I guess we'll.
We usually there will be migrations and stuff to
True.
architecture. So yeah.
True. Next question.
Shouldn't we really minimize the use of comments? Because if another person modifies my code in the future and forgets to modify the comments, then the comments will not be consistent with the code. Yes. So as Mira has pointed out, comments should just be something extra that the reader of your code cannot get from it. Like, I mean, we are all programmers, right? When you read a code, you roughly know what's going on. Comments is the extra part, like what you have to keep in mind. And also, if I'm going to modify Mira's code, I would generally a good practice to modify the comment if the comment it doesn't really kind of sync with my code.
Right.
Yeah.
I think this is why it's important to, I guess, use it when necessary, and don't try to replace your code in the comment itself, and just leave the ones that it's precisely the reason why. Sometimes comment itself gets out of sync and out of update. And when you look at the code, it doesn't really match, right?
No. In my team lead ensures that the comment is updated with the code.
See?
He'll be like, can you please make another CL to change a comment? I was like, really? Oh,
yeah. Like a little bit annoyed, but okay, fine. Makes sense.
Wait, there's another question. I heard that software engineers are evaluated by numbers of lines of codes are passed. So is there a minimum amount of lines to complete? No, actually no.
What kind of rule?
Actually, no, there's no rule such. If you can actually implement and change something simply with lesser amount of code, it is actually very admirable. I don't know. That's my view. How about you?
Never by the number of lines.
I don't know. It doesn't
I
go
might.
by that.
If it's that way, I might actually.
No, but then, but then if that's the way, then it's easy, right? You just create a big dictionary of stuff that spans hundreds of lines. No.
That I think that actually kind of goes against what we covered today. Keep it simple. You ain't gonna need it.
Any more questions? You can ask more questions in the chat. Let me see.
Oh, there's some questions. Can I ask you?
Oh, okay, sure.
Interviews at Google are 45 minutes. Okay. I guess some interviews are. What advice do we have? Do you have to use all these? What advice do we have time to use all these principles?
Actually, during interviews, I think most importantly, what the so-called the interviewer is looking for is what kind. Do you have the right idea? Can you implement it? Of course, if you can implement it in a very readable way, that's awesome. And if you cannot do that, then maybe perhaps it's better to talk through with your interviewer what you're trying to do, rather than diving into writing complicated codes. Right. And then there's a constraint of time. You get nervous.
Yeah. True. Yeah. Because remember, interviewer can really read your mind. So it's important to actually think aloud. So that's, I think, what interviewers are looking for, your train of thoughts and how you get to the answer. I think it's actually sometimes more important than actual solution and answer itself.
And then one more trick is that, is always try to scope the question. Sometimes the interviewer will purposely ask a very vague question. The answer, so they are just asking, if you can question, can I just scope this question a bit? Can I write it for this case only? And then the interviewer will be most likely be impressed, right?
Easier for you and easier for interviewer.
Yeah. Oh, there's a question, I think. Is it fine if the comments explain the workflow of the program, or is it unnecessary?
I think it also depends. So say like, I don't know, for whatever reason, your code is pretty long in a way, and you think it's going to be used by a lot of other teams. Sometimes the person who are calling your function or method, like may not have to know everything that goes in your code, right? So as long as, I know what to pass in and I know what it will return. And if I can find that out by just reading the comment, I kind of like that. I don't know.
Okay, so I have two trains of thought. So if the workflow, if the program is very complicated and there's a workflow and there's architecture, then I would advise having a documentation, a design documentation that talks about the workflow.
Right.
And then the code, you keep it simple. Thank you, for this question.
Yeah.
Oh, and there's a question from Hiju.
Okay.
How much time is usually spent on peer code reviews versus actually writing code?
That's so interesting. I've had a conversation with my friend the other day. Her complaint was like she spends so much, like all day pretty much she reviews code and no time to code herself. So I think as you get more senior, sometimes the time you spend to write the code versus
maintaining the code health,
maintaining might actually
get a bit lopsided. So when you're usually when you spend more time reviewing codes when you're like the originator of the system, then everyone wants to consult you because you understand the architecture the best. Then you probably spend more time trying to review the codes. But if you're new to the system, usually you spend more time trying to integrate with the system. You'll be writing more code instead.
Yeah. And as you mentioned, like while you're reviewing, you actually learn new things as well because you're reviewing someone else's code and they might be doing things slightly differently than how you would do it. So I guess that gives you different ideas.
Yeah. Is there any more questions? Let me see. Can you share more about your journey entering Google?
Oh, wow. Quite interesting. Very personal. But so I've been working in Canada for, 5-6 years. And then because my family still lives in Asia, I just wanted a change and I wanted to move back to back home. And I was looking for, jobs out here in APAC. And I must tell you, I've applied to quite a few jobs. And then I got an interview at Google, and then kind of things worked out. And actually, my current job is second job at Google. So I was working in advertising industry as my first job, and now I'm working in Android system team. How about you?
Slightly more complicated. I started as a researcher in the defense industry.
Oh, wow.
Yes, I was a researcher for a long time. Then after that, I decided to try something new, so I joined a startup. I was in the startup for about 2+ years. It was very busy because it's a startup, it's
you do everything.
You must get everything out. It's very prototyping.
It's a 3-month.
It's a 3-month cycle. And then because the code is short, so we can excuse a bit of code health, but then you still pay the debt. In the end, what I learned is that you still pay the debt. And that's when, when the client say, I want to sign on this project. Can you please productionize it? I was like, oh no. I have to refactor everything. And sometimes you go back and read it. What is this trying to do? Oops.
Right.
Yeah. Then after that, I decided to get married and settle down and, start up So the work-life integration doesn't really work out.
Mhm.
So I joined Google.
Oh, so
yeah.
Google has good work-life balance.
Yes.
Okay, good to know.
Let me see any more question.
I think we're good.
I think we're good.
Yeah.
Okay.
Well, thank you everyone for joining and staying with us.
Mhm.
It was 45 minutes of a lot of things packed into it.
Mhm.
Hope you enjoyed it and hope you get something out of it today.
Yeah.
Thank you. Thank you, everyone.
Bye-bye.